there are different types of error detection. One is single parity checking, and second one is checksum. Next one is polynomial codes or CRC. This technique generates the total number of ones even, so it is known as even parity checking. Whatever the checksum sum is generated, it has to be complemented, and once if it is complemented, then if the result is 0. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Students, let us start our discussion with the concept of data link layer. It is in Unit 2. Unit 2, the chapter is data link layer. So, in this session, we are going to talk about data link layer, what are its responsibilities, and types of error detections during data transmission. So, there we have single parity check and checksum. These are the concepts to be discussed in this session. So, let us start with data link layer. So, what is data link layer? You know what is OSI reference model. So, this is the second layer from the bottom in the OSI reference model. Now, you know OSI reference model, it is a 7-layer model. So, data link layer is the second from the bottom. Now, what are its responsibilities? So, it is responsible for node-to-node delivery of data. That's the one point. Next one is to ensure error-free transmission of the information. So, the major responsibility is this is to provide delivery of data from one to another node or system, and it should be error-free transmission of data in the network. Next one is it is also responsible for data encoding, decode, and organize the outgoing and incoming data. This is another responsibility of data link layer. So, encoding, decoding, and organizing the data during the data transmission at the receiver end. Next one is it is also hides all the underlying complexities of the hardware from the other above layers. So here this is a second top layer. From the bottom it is the second layer. The first layer is the physical layer. So it is going to connect the two systems physically, or that is a physical connectivity between the two systems. But next we have data link layer. So it is going to hide. So it's going to hide all the underlying complexities of the connectivity or from the network, from the host to the destination. These are the different responsibilities of data link layer in OSI reference model. In the next slide, we will see what are error detection. So what is the meaning of error detection? So whenever there is a data transmission from sender to the receiver, so there are chances of errors. So it may be of different reason. So how do you find the errors, or how to detect the errors, and how do we overcome? That is the concept of error detection. So here in this, when the data is transmitted from one device to another device, the system does not guarantee whether the data received by the device is identical to the data transmitted by the other device. So here, this is the concept of error here. So the sender send the message from his system, and the receiver, he has to receive the same data what the sender has sent from his system. So if the receiver end, if he receives the same identical data from the sender, or how the sender has sent the data in the same format, then we can say that there are no errors during data transmission or in the network. But if the data received at the receiver end is not identical to the sender's data, or what the data has been sent from the sender, then we can say that there are some errors in the network. So here the error is a situation when the message received at the receiver end is not identical to the message transmitted. So this is the meaning of error detection method. So and here the types of error detection. So here we can come across there are different types of error detection. One is single parity checking, and second one is checksum. Next one is polynomial codes or CRC. These are the different methods to detect the errors in data transmission. In the next slide, we will see what is a single parity check. Single parity checking is the simple mechanism and inexpensive to detect the error. This is one of the simple method. And in this technique, a redundant bit, it is also known as parity bit, which is appended at the end of the data unit so that the number of ones becomes even. So here, as you know that, the data is transmitting in the network in the form of packets or in the form of a group of frames. So here, another bit is called a parity bit or redundant bit is going to append at the along with the data so that it makes the number of ones is even in the data or in the data frame. Now, therefore, the total number of transmitted bits would be 9 bits, and if the number of ones bits is odd, then parity bit is 1, A1 is appended, and if the number of ones bits is even, then parity bit is 0 is appended at the end of the data unit. So here, what the concept here is, suppose the data is in the form of bits and bytes or is a combination of zeros and 1. So here, if the data transmitted by the sender, if it contains the even number of ones, if it contains the even number of ones in the frame, so then we have to add 0 bit as the parity bit along with the data. So suppose if the number of ones is odd in the data frame or in the frame, then we have to add 1 so that we have to make the total number of bits should be even. So this is the concept here. Now at the receiving end, the parity bit is again calculated from the receiver data bits and compare with the received parity bit. So the sender he has to transmit the data. The data is divided into number of frames, and while transmitting the data is going to add 1 bit as a parity bit. It depends on the even number of ones or odd number of ones. If it is the even number of ones in the data frame, is going to add 0 as the parity bit, and if the number of ones is odd in the data frame, then it's going to add 1 as the parity bit at the MSB, that is most significant bit. Then both the data along with the parity bit is transmitted over the network. The receiver end, again it checks for the parity bit and number of data frames or number of ones in the data bits or in the data frame. And again it checks for the parity bit of the received data from the sender. So this technique generates the total number of ones even, so it is known as even parity checking. So here at the receiver end, it checks for even number of ones at the receiver end, so it is called as even parity checking. So at the receiver end, if the number of bits is odd, is going to reject the data. That is the concept here in single parity checking. Now look at the diagram here. So here there are two systems, one is sender and another one is receiver end here. So the sender, he sends the data. So this is the data sent by the sender, and here you can make out the data is 1 1, 4 zeros and 1. Now if you look at this here, in the given data at the sender end, there are 3 ones, that is odd number. 3 is odd number, so is a odd number data frame. So then it is going to generate a parity bit, that is 1. So that it makes the total number of ones is 4, that is even number. So at the sender end, it's going to generate a parity bit as 1, and it will be appended at the MSB. This is, if you look at the data, this is LSB, least significant bit, and this is the MSB, most significant bit, and this parity bit in this example is a 1, is going to add at the MSB. Now along with this parity bit plus the data, it transmitted over the network. At the receiver end, so here first it checks for the parity bit. So here in this example, 1, 2, 3, 4, there are 4 ones in this data with the parity bit. At the receiver end, it checks for it. So if it is even number of ones, then if it is even number of 1, then data is accepted at the receiver end. Suppose if there is odd number of ones, then data is rejected. It means that there are some errors in the network or during data transmission. Now, for example, how can we say data is rejected here? In the example, if you look at, suppose if the receiver, at the receiver end, if he receives the data, for example, as this is what parity bit, this is the parity bit, and here 1 1 0 0 0 0 1. So here 1 0 0 0 0 0 1. If you look at compare this, suppose the receiver, he receives the data is in this format. Then by looking at this, here the data parity, this is even number and is even. This is the parity bit is even. Now if you look at the data here, 1 plus 1, yeah, this is 1, 3. There are 3 ones including the parity bit. So 3 is odd number. So this data frame consists of odd number of ones. In this case, the data is rejected. Now if you observe this, here there is 1. This is okay. This is also right. And if you look at this 0. So in this example, this 1 is changed from 1 to 0 at the receiver end. It means that there are some problems during data transmission. This example, in this case, this particular data is rejected from the system. This is the concept of single parity check error detection method. In the next slide, let us see what are the drawbacks of single parity checking. So here it can check, is only detect the single bit errors which are very rare, and if 2 bits are interchanged, then it cannot be detected the errors. So this is the drawback of single parity check error detection method. Now let us go for next concept or next method, that is called checksum. So what is checksum here? A checksum is an error detection method. Is another error detection method or a technique based on the concept of redundancy. Now, what is the meaning? Again, here they are divided into, there are 2 parts here. One is checksum generator and checksum checker. So this is another method of error detection in data transmission over network. So now let us see the definition of this. The checksum generator. So here it is going to follow at the sender end. At the sender end is going to follow this procedure. Here the block unit is divided into k sections and each of n bits. So here this is the block of data is going to divide into number of blocks into number of sections. For example, k sections, and each sections will be having n number of bits. So this is the step number 1. Then all the k sections are added together by using 1's complement to get the sum. So here the number of k sections, all the sections will be added together with the help of or with the concept of 1's complement form, and we is going to get the sum. So here the sum is complemented and becomes the checksum field. So once after adding all the k sections data, and we are going to get the value that is called sum, and it will be appended at the along with the data. So it is called as checksum field. So that is the meaning of checksum. And original data and checksum field are sent across the network. So data along with this checksum which is generated by adding all the k values or a data at the section k sections, and to get the sum it will be appended along with the data, and those data plus checksum will be transmitted over the network. So this is the procedure at the sender. So at the sender, first is going to generate the checksum. Next one is, now look at the diagram here. So this is the sender and this is the receiver at the receiver end. And between, this is a data communication or data transmission. So here, this is what we're talking about. Here in this example, the subunit 1, this is 1, 2, and these are called sections. As we have seen in the definition, divided into K sections. So this is section 1, section 2, and up to section K. There are K sections, and each section will be having n bits. So this is, each section will be having n bits. So this is number of bits. Here is n. And how do we get the checksum here? By adding these two. First, we have to add unit number 1, and this is section 1 and section 2. We have to add these, and we'll get the checksum here. This is the checksum value. This is the sum. Again, we have to complement this with the ones complement. So again, we add that to another section K here. So at the end, we will get sum that is of n bits. Once if we get sum, I mean after adding all the values, all the data from all the sections, from 1 to K sections, we'll get the sum. And this has to be complemented. Once it has to be complemented, it's going to generate the checksum. That is how the checksum is generated at the sender's end or the sender system. And this checksum, along with the data, is transmitted over the network to the receiver end. Again, at the receiver end, the data whatever is received at the receiver end, again it will be divided. Same procedure will work out here. So same entire data is divided into number of sections, K sections. So section 1, section 2 up to K section, and each section will be having n bits of data. And same procedure to be followed here. Again, we have to add these two, section 1 and section 2. The data of section 1 with n bits, we have to add these two. We will get the sum, and we have to complement the sum to get the checksum here. Again, what we get from here, it has to be added to next section, that is section K up to section K. Then we get the sum. And again, whatever the checksum sum is generated, it has to be complemented. And once if it is complemented, then if the result is 0, if after complementing the sum at the receiver end, if the result is 0, means if the complement is 0, then it is the data is accepted. So there are no errors in the data transmission for any type of data. So this is the concept of, this is checksum generator. So checksum generator is at the sender end, and same concept of the receiver end, that is checksum checker. Again, the checksum checker, it is verified. This is verified at the receiving side. So here, the procedure, we have to follow the same procedure here. The receiver subdivides the incoming data into equal segments of n bits each. So this is what we have seen at the receiver end. Each data received at the receiver end will be divided into number of sections, K sections, which n number of bits. And here, and all these segments are added together, then the sum is complemented. So we get the sum that has to be complemented. If the complement of the sum is 0, then the data is accepted, otherwise data is rejected. Here, we have to sum up, we have to sum all the units one after another with one's complement form. Then after that, we have to get the sum, we have to complement the sum. So if the result is 0, where the result is 0, then the data is accepted, otherwise data is rejected. So the receiver follows the given steps. So same thing has to be done same process has to be followed at the receiver end. So this is nothing but the checksum checker. So in this example, checksum is a type of a method of error detection during data transmission in a network. So there are two stages. One is checksum generator. It is at the sender end, and checksum checker or nothing but is a verification. So it check for that. And finally, at the receiver end, if after summing up all the data at the receiver end or all the key sections, we have to complement it, and if the complement is 0, then data is accepted, otherwise data is rejected. If the complement is not 0, then it is understood that there are chances of errors or data loss or data corruption during transmission in the computer network. Students, so far we have discussed about the data link layer, the responsibility of data link layer, and error detection methods. And there we have discussed about one is single parity check and second one is checksum. These are the two methods of error detection during data transmission in the computer network. We will continue our discussion in my next session. Thank you very much.